Hello students, myself Sheetal Patil. I would like to present on refractometry. After this presentation, learner will able to know definition and basics of refractometry, explain principle of refractometry, and list factors affecting refractive index. Study different parts and working of Abbe's refractometer. Introduction to refractometry. Definition of refractometry is measurement of the extent of light which is refracted. The phenomenon is known as refractometry. It is used to determine refractive index. It can be represented as R dot I dot. It's a unitless number. For liquids, its range is between 1.3 to 1.8. For solids, its range is between 1.3 to 2.5. Refractive index is equal to eta 20 on the superscript and D at the subscript we should write. 20 represents the temperature at which refractive index is calculated and D is the wavelength of light. Now the principle of refractometry. You can see this figure. When the beam of light passes from one medium to another medium of different density, an abrupt change in the direction of beam of light is observed due to differences in velocity of light beam in the two media. This bending of light beam on passing from one medium to another is called refraction. The angle between the incident ray and the normal to the dividing surface is angle of incidence, whereas the angle between refracted ray and the normal dividing surface is called angle of refraction, which is represented as R, and incident angle is represented as I. So refractive index of the second medium with respect to first medium can be written as eta R is equal to sin I upon sin R. Refractive index with respect to velocity can be written as eta R is equal to velocity of air divided by velocity of liquid. Now, students, pause your video and write down the answer of this question in your notebook. Question is, what are the factors which are responsible for change in the Ri? Whatever introduction we have seen, from that you can able to write what are the factors which must be responsible for refractive index. So please write it. Now you can start your video. These are the factors which affects refractive index. The first factor is wavelength. The refractive index of a transparent substance gradually decreases with increasing wavelength of radiation. This is called dispersion. Because of this, the wavelength must be specified in quoting the refractive index of the substance. Second factor is temperature. The refractive index of the liquid varies with temperature. This is due to corresponding change in the density of liquid. If the temperature increases by 1 degree Celsius, refractive index decreases by 0.0004 to 0.0005. Next factor which affects refractive index is pressure. The refractive index of a substance is directly proportional to pressure because of corresponding increase in the density of a substance. Now, we will move on to the refractometer, which determines the refractive index by measuring the position of critical ray. This is the diagram of Abbe's refractometer. If you see this particular diagram, Abbe's refractometer has different parts. This is eyepiece. This is thermometer to monitor the temperature. This is coarse adjustment knob. This is fine adjustment knob. This is upper prism This is lower prism. In between these two prisms, a sample is placed of which refractive index to be determined. Then above upper prism there is compensating amici prism to adjust the drum, and this is to this eyepiece another eyepiece is present, which is known as scale eyepiece. This is movable light source. So this is how the Abbe's refractometer looks. You can practice for the drawing of this Abbe's refractometer. Now this is a schematic representation of Abbe's refractometer. In this, a beam of white light reflected from a mirror enters into the lower prism. This is lower prism, which is called illuminating prism, whose upper surface is rough, which act as a source of infinite number of rays, which passes through 0.1 mm thin layer of liquid in all directions. These rays then pass through the polished surface of upper prism and produces a critical boundary-like rainbow. This is due to the dispersion effect. To eliminate the color band, an auxiliary optical system called compensator is incorporated in the telescope. You can see the telescope in the diagram where the two amici prisms are placed for the compensation. The optical compensator sharpens the boundary and produces a critical ray with white light, which is equivalent to that with sodium D line critical ray. Thus, the refractive index measured with Abbe's refractometer equals to ND. D is for sodium light source. These are the references that I have referred. Thank you for patience listening.